Alright, this is the final part of the review where we're finding discontinuities in functions. And for the first two problems here, when you're finding discontinuities, you always want to factor the function first. Factor the top and bottom and see if anything cancels and whatnot. So for number 22, I would factor the top into x plus 3, x minus 3. And the bottom is just x minus 3. And I notice that the x minus 3's cancel. And when something cancels, that creates a whole. So if a factor cancels, that factor creates a whole. Creates a whole. And the way you find where the whole is you simply set that factor equal to 0 and you solve, and this function has a whole at x equals 3. So there's number 22, and there's nothing else. Whoa, how many 22s are there? This is confusing. Alright, well that's the first number 22. 22 the second. Again, we're going to factor. My top is a difference of squares, and we're going to start by factoring that into x squared plus 4 and x squared minus 4. The bottom factors to x plus 2, x plus 1. Okay, on top, I notice I have x squared minus 4, which will continue factoring into x plus 2, x minus 2. It's a difference of squares. X squared plus 4 does not factor at all. You cannot factor a sum of squares. That doesn't factor. And then x plus 2, x plus 1 on bottom is already cleaned up as far as it can be. And then I cancel x plus 2. And if something cancels, that means there's a whole. So I have a whole wherever x plus 2 is equal to 0. And that happens at negative 2. So x equals negative 2 is a whole. And then if you have any factors remaining, x plus 1 did not cancel. So if you have any factors remaining in the denominator, that is an infinite discontinuity. That is horrible penmanship. Let's try that again. Infinite. Or you could call it a vertical asymptote. Vertical asymptote. And you find the location the exact same way you set it, you set that factor equal to 0, subtract 1, and you get x equals negative 1, and that is a vertical asymptote, or you could call it an infinite discontinuity. I misspelled infinite. Infinite. There we go. Alright, so there's 22. So you want to factor and cancel. If anything cancels, that creates a whole. If anything is left over, that is an infinite discontinuity or a vertical asymptote. And then the last one is a piecewise. And if you have a piecewise, there is a possible jump wherever the piece changes from one function to another. So this happens at x equals 3. So there is a possible jump at x equals 3. And the way you determine whether or not there is a jump at x equals 3 is you look at the limit on both sides. So I'm going to find out by doing the limit as x approaches 3 from the left. Sound like a smoker's cough. So as I approach 3 from the left, this is my left side right here, and if I plug in 3 to that function, you get 1/3. And then I will also do the limit. And I will also do the limit as x approaches 3 from the right. And the right side of 3 is this piece right here. And my right side, 3 plus 1, is 4. Alright, my left side and right side are going to two different places. So since they're going to two different places, we have different answers. And if you get different answers for the left and right side of 3, that means there is a jump. Therefore, there is a jump at x equals 3. So we do have a jump because left and right sides were different. If left and right sides were the same, then you would have to test for continuity by also evaluating f of 3 and seeing if the function is continuous or not continuous based on that limit definition of continuity. Okay, now you think you're through, but there's also a hidden discontinuity in this one that everybody misses, and that happens with this piece right here. Remember, if you have a fraction, and this is kind of what we were thinking about on the 22s here, if you have a fraction, if anything makes the bottom 0, that is a discontinuity. For example, in 22, the x plus 2's canceled, but that was a 0 on bottom at x plus 2, and that's where the hole was. X plus 1 gave me a 0 at -1, and that was a vertical asymptote. Well, if you look at this piece, for the right side, or for the left side of 3, I'm looking at 1 over x. Man. Hopefully I won't die in the middle of this. Alright, so I'm looking at the 1 over x part. For 1 over x, there is a vertical asymptote at x equals 0. And it's a vertical asymptote because that doesn't cancel, and 0 makes my bottom 0. And 0 is less than 3. We use 1 over x for x values that are less than 3, and since 0 is less than 3, there is also a vertical asymptote at 0. So you have to consider that little hidden piece also. If you look at x plus 1, there is no denominator. There's nothing funny with x plus 1 that we need to think about. So we are done with these discontinuities.